everyone, my name is Melinda Pulisetti, Health Informatics graduate student from George Mason University. Over the past semester, Rahul, Vibha, and I have been working on projects aimed at tackling one of the most serious global health challenges, that is, depression management, under the guidance of Dr. Farrokh Alemi. These projects are a part of a larger AI driven initiatives designed to improve how we diagnose, treat, and coordinate care for patients dealing with depression. I'm going to walk you through the background of our work, the larger framework we're contributing to, and our team's focus project, that is, the common AI challenges. To provide some background, depression is one of the leading causes of disability worldwide, affecting over 280 million people annually. What's particularly challenging when it comes to depression management is that 60% of patients do not respond positively to their first prescribed treatment. This creates a frustrating trial and error process that delays the relief to people who need it the most. Adding to this issue, there is also factors like social stigma, varied response to treatments, and limited access to personalized and discrete care. This is where AI comes in. By analyzing patterns like medication changes and treatment durations, we can predict remissions with good amount of accuracy. Now let's dive into the 5 components that form the backbone to our AI-driven initiative to manage depression. The first step is the common AI challenges that focuses on enhancing how the AI chatbot collects and processes the patient data. By improving the interactions with the chatbot, we can lay a good foundation for accurate diagnosis and improve the proceeding steps. And the next step is analyzing missing values. It addresses the gaps in patient data and ensures complete and accurate data sets. The third step is removing algorithm bias that focuses on identifying and correcting the biases in AI's recommendations, whether related to race, gender, or any other demographic factors. And the next is actionable AI advice. Here we use predictive models to give customized treatment plans based on patient data. This supports clinicians in making informed and evidence-based decisions. And lastly, we have the patient follow-up, which ensures continuity of care by tracking the progress over time and refining the system for future use. Together, all these 5 interconnected steps work and help us build a system that delivers personalized and effective care for people dealing with depression. Now let's talk about our focus project, the Common AI Challenges. This project is all about improving how the chatbot collects and processes the patient information, which is a critical first step in making the AI system for depression management work effectively. The goal is to fix the issues in the intake process and help the chatbot recognize serious risks like suicidal thoughts, and also ensure conversations with the users are clear, logical, and also helpful for the patient who is chatting with the chatbot. The intake process is the foundation to the entire depression management systems because it ensures better diagnosis, personalized treatment recommendations, and also makes the interactions smooth between the chatbot and the user. My teammate Vibha will take over and discuss about the methodology that we used for this project. Thank you.
Thank you, Melinda. My name is Vibha, and I will be discussing about evaluation methods, prompt construction, and problem identification. AI chatbots play a critical role in mental health care. Hence, a systematic and collaborative approach was adopted to evaluate operational efficiency, and an evaluation framework was designed based on adversarial testing. The chatbot was challenged with scenarios that mirrored real world interactions, including ambiguous inputs, alternate clinical terminologies, and crisis situations, such as suicidal ideation. We focused on 3 aspects: the chatbot's ability to confirm depression diagnosis explicitly, its capacity to detect and manage suicide risks, and its effectiveness in retaining conversational context during extended interactions. Each test scenario was meticulously crafted to uncover deficiencies with evaluation metrics focused on diagnostic accuracy, the appropriateness of safety mechanisms during crisis, and the chatbot's consistency in responding to ambiguous user inputs. This rigorous testing ensured that every potential flaw was identified and addressed systematically. To support our evaluation, a series of prompts were developed. For instance, we included cases where users expressed symptoms in non-standard ways or presented vague indicators of distress. These prompts were not just about testing surface level interactions, but also evaluating the underlying algorithms for maintaining context and providing responses aligned with clinical standards. We diagnosed two problems with the chatbot. The first problem we came across was premature diagnostic assumptions. A conversation screenshot on the left side of the slide demonstrates the chatbot progressing with depression diagnosis without receiving a clear yes or no response to a direct query about the user's mental health and symptoms. The second problem was inconsistent detection of suicidal intentions. A conversation screenshot on the right side of the slide illustrates a situation where the chatbot initially acknowledges the suicidal ideation, but subsequently provided inconsistent and inappropriate responses in further prompts of suicidal ideation without obtaining explicit confirmation from the user. The first problem showcased the chatbot assumed the presence of major depression without obtaining explicit confirmation from the user. This premature assumption could lead to misdiagnosis and inappropriate recommendations, undermining the reliability of the system. In the second problem, we noticed that the chatbot failed to recognize explicit and implicit suicidal ideation consistently throughout conversations. While the initial response to suicidal cues was appropriate, follow-up prompts often missed critical indicators, providing inadequate or irrelevant replies. I would now like to invite my teammate Rahul to discuss solutions.
Hello everyone, I'm Sairol Baljapalli and I'll be discussing the proposed solutions to improve the chatbot. The main goal of this project was to identify deficiencies in the chatbot, propose targeted solutions, and validate the changes to ensure those deficiencies are properly addressed. The three key solutions we proposed were prompt engineering to improve the baseline prompts, a universal suicide detection control to assess suicidal intent throughout the conversation, and train the chatbot with extensive clinical domain knowledge using the retrieval augment generation system. The mental health AI chatbot is built on the OpenAI and Llama platform through APIs. These APIs allow the chatbot to leverage the underlying large language models to interact with the users, collect history, and detect suicidal intent. We propose defining the base level prompts in the system and passing them to LLS to provide the chatbot with clearer guidelines, ensuring it applies context more effectively, reduces digression, and improves its ability to detect suicidal intent. Additionally, we proposed a universal suicide detection controller which continuously monitors and assesses suicidal intent throughout the conversation. Finally, we propose training the chatbot using a retrieval augment generation system, which allows the model to retrieve relevant clinical information from external sources and generate more accurate, contextually appropriate responses. This ensures that the chatbot remains grounded in the mental health domain and can provide users with accurate, relevant support. These proposed changes directly address the identified deficiencies in the chatbot. Looking at the chatbot's responses after the implementation of the changes, we can clearly observe two key improvements. The chatbot no longer proceeds to further stages without receiving explicit confirmation from the user, ensuring that the conversation moves forward only when the user confirms their reported symptoms and depression diagnosis. The chatbot avoids digressing when prompted with reasoning-based questions, staying on topic, and maintaining the flow of the conversation. Here, we can observe the chatbot reacting accurately to signs of suicidal intent and guiding users towards relevant resources, providing timely and appropriate support. I would like to conclude by highlighting the importance of the AI system and the role of the chatbot in the intake process. The chatbot and its design functions to capture the user's history, detect suicidal intent, provide resources for coping with mental health challenges. By offering personalized treatment recommendations based on accurate user history, the chatbot ensures accurate, safe, and personalized care. This innovative care approach can reduce costs, minimize visits, and prescriptions for both patients and healthcare providers. I would like to extend my heartfelt thanks to Dr. Farooq Alimi for providing us the opportunity to work on this revolutionary mental health tool. I would like to also thank Amaljeet, Vlad, Srivani, and my teammates Vibha and Melinda for their collaboration and support during this project.